Hello everyone and welcome. In this video we're going to be talking about why CVTs are actually pretty awesome transmissions. And a lot of people love to hate on CVTs and say they're soulless, and I do agree, I think they are, but I don't think any more so than any of the other automatic transmission styles out there. So a manual transmission, it's a lot more involved, and as a result people like it. They say it's more fun to drive, but things like dual clutch transmissions, these are justified as being acceptable in these high-end sports cars because they're quicker, so they post faster lap times, faster acceleration times, they shift much quicker, and so they're considered better because they're faster. And so by that same logic, that's why I want to talk about CVTs, and people hate on CVTs because they can sit at a constant engine RPM. And so as a result of this, marketing departments have told manufacturers we can't have these constant engine RPMs, we have to have stepped gears, and so now they sound just like every other transmission out there, except they've completely defeated the purpose of the CVT transmission in doing that. That's not the manufacturers to blame, that's the consumers. Consumers don't understand it, they don't like it, they complain, and then so as a result manufacturers have to change it. This is a long rant that's pointless, but anyways, CVTs today, they're marketed in a way where they're engineered kind of in the wrong way. And so that's what we're going to get into here. So in a given gear, this is our first question to kind of explain why CVTs are actually really cool. In a given gear, where does maximum acceleration occur? And so here we have kind of a torque curve of a 2008 Z06. Of course, does not have a CVT transmission. And the question is very simple. Where does maximum acceleration occur in a given gear? It's of course going to occur at peak torque. And if you're curious about the math, there's the math right there. But the point is you're going to have a bunch of different variables, all of which, because you're in one gear, will be held constant except for torque, which is right here. So your gear ratio is constant, your final drive is constant, the radius of your tire, and the mass of your car is constant. So the only thing affecting acceleration that changes is torque, and as you can see, when it's at its peak, that's when acceleration will be the highest. So that means your maximum acceleration in a given gear is at peak torque. And that's okay, but what we want to know is at a given vehicle speed, where is maximum acceleration? Because that's where you want to sit at, and we'll explain why. So here's kind of the complicated math portion of this video, but we know that power is equal to force times velocity. That's one of our given equations. Another one of our given equations is horsepower is a function of torque and RPM. So we can set these two equal to each other. Now, of course, there would be a 5-2-5-2 divided underneath these if you're using the imperial system, but regardless, horsepower is a function of torque and RPM. So we can say that force times velocity, setting these two equal to each other, power equals power, is equal to torque times the engine RPM. So then we can divide velocity on the other side, F equals T times W divided by V. We know also that force is equal to mass times acceleration. We can set these two equal to each other, and now we have an equation with acceleration in it, so we can find out what max acceleration is. So that gives us acceleration equal to torque times your engine speed divided by velocity times the mass. And so we're at a given speed, so V is going to be constant, M is going to be constant, the mass of the vehicle. T times W, of course, is equal to horsepower. So our maximum acceleration is going to occur at maximum horsepower right here. And so it's not going to occur at peak torque at a given vehicle speed. So why is that? And this is kind of the interesting part. So let's say we're in this Corvette, we're in third gear, and we're at this peak torque right here. But if we were to downshift, we could be at our peak horsepower. So you're going to be at less torque, but you're using a lower gear ratio, or a higher gear ratio rather, and as a result of that, you're going to have more wheel torque because, as our equation shows right here, your force at the wheel is a result of your gearing through your transmission. Okay, if you're still following, which hopefully none of this math is very complicated, it's just simple algebra, you divide a bunch of different equations. So we have 505 horsepower is equal to 6,500 RPM times torque. The torque at that divided by 5,252. So that's how we can figure out torque. And so we have 408 pound-feet of torque right here versus 475, which is our peak. So we're at less torque, but we've got a greater gear ratio. So what's the gear ratio difference? Well, if you divide 6,500 by 4,800, that would give you your gear ratio difference, 1.354. So a 35% more aggressive gear ratio. So we take 408 pound-feet of torque, which is what we produce right there. We multiply that by that gear ratio, 1.354. That gives us 552 pound-feet. which is going to be, going to the wheels versus 475 from the engine. And so, this is assuming you go through the transmission, and this would be a 1-to-1, this would be a 1.354-to-1 ratio. So 552 divided by 475, 1.16. So what that means, what all of this math here is demonstrating, is that if you were to be in this gear right here at this point in time accelerating, you would be accelerating you'd have 16% more torque at the wheels, 16% greater force at the wheels than you would if you were in a gear that put you at peak torque. So that's the critical thing. The critical thing is that you always want to sit at peak power if you want maximum acceleration. So, a lot of people will look at their torque curves and say, okay, when should I shift gears? That's not what you should be looking at. You should be looking at how do you keep yourself at maximum power, because, your torque can taper, but you'll still have more wheel torque as a result of the gear ratios. Okay, so where we're putting this all together and getting back to the reason why CVTs are awesome is looking at wheel force versus vehicle speed. Okay, and so maximum acceleration would be if we were to just follow peak horsepower and change the gear ratio accordingly. But because we're in this Corvette, which has a 6-speed transmission or whatever it has, you're going to have this. Here's going to be your first gear right there. That's what your force at the wheels is going to look like. You'll hit peak torque, and then it'll start to taper down, but you'll get into peak power. So you'll follow that curve as you're getting into those higher RPMs. And then, you go into second gear. So your wheel torque is going to drop, and then you're going to go over here. And then you're going to drop as you go into third gear, and then you'll start to follow the curve again. Drop as you go into fourth gear, start to follow the curve again. And so a manual transmission, an automatic transmission, a dual clutch transmission, anything with gears, you're going to have this step where you lose a bunch of wheel torque instead of following the ideal curve. And that's why a CVT is so awesome, because what a CVT does is it just adjusts the gear ratio. That's all it does. And by just adjusting the gear ratio, you can sit at maximum acceleration. So the car can accelerate as fast as is humanly possible. Humanly probably isn't the right word, but physically possible for that car to go through it, because it just sits right on that curve. And so kind of a problem with CVTs is they haven't really been developed for very high torque applications. They're used more economically, and that's probably a demand thing. I mean, nobody really wants a supercar with a CVT. But if you were to have a supercar with a CVT, it would be quicker than what the supercars are currently using with their dual clutch transmissions. So I hope you guys have learned something from this. Hopefully just a slight ounce more respect for CVTs, because they actually are really cool in how they work. I also do have a video illustrating how they work, which you may want to check out. And one final thing, a lot of the math from this video came from this book, Physics for Gearheads. It's a pretty cool book if you actually do like math. If you don't like math, you're probably going to be a little disappointed, but it breaks down the math of a lot of cool ideas, a lot of different automotive concepts, and makes it kind of easy to understand. So a pretty cool book, and I'll include a link to this in the video description. Thank you all for watching, and if you have any questions or comments, feel free to leave those below.